Thanks for the introduction, Chris. My name is Jared. I'll be giving you a presentation on basic malware analysis for incident responders. And feel free, as I'm explaining things, I'm going to have a lot of screenshots, so feel free to just raise your hand if you have any questions. And I'll be standing back here pointing out some key points on the slide with the laser pointer here. So here's the agenda for today. So the goal of this presentation is to go over static malware analysis techniques. And then in response to that, I'm going to go over some evasion techniques that malware authors will use. And then kind of the back half of it is the response that you could use to some of those evasion techniques. And we can skip this. Chris just gave a great introduction, so thanks, Chris. I did want to give a quick shout out, though, because they did fly it from DC. My coworkers that I work with Nightwing at, Dave and Carlotta. Back there, Carlotta's my supervisor, and Dave's my coworker. So the goals of this presentation is to give basic understanding of malware analysis to find some indicators of compromise. And then I'm also going to show some evasion techniques that malware authors could use to avoid some of these types of detections. And really, this isn't meant to be a detailed class on reverse engineering. It's just kind of an intro into malware analysis. So I'm going to start off by going over a couple virtual appliances, which is Remnix and Flare. So when you're performing malware analysis, you need to have an environment in which you're doing it. So these are, I would say, the two most popular, and they kind of serve the same purpose. The main difference between the two is Remnix sits on a Linux distribution, where Flare is a collection of tools that will sit on a Windows 10 or Windows 11 operating system. And which one to choose, you're going to find that most malware analysts are going to use both, but in this presentation, you're going to see a lot of screenshots from my Remnix VM. And I just wanted to touch on the installation of the two because they're slightly different. So Remnix, and just to point out, they are both free and open source, so those links right there, you can go access them and download them yourself in your home lab. And the main difference is Remnix comes pre-packaged into an OVA file, where Flare is a little bit different. It's a collection of scripts that was developed by Mandiant, and you need to download the Windows VM first and then install the Flare Git repository on top of that VM. So before I get into the specific techniques of malware analysis, I just want to do a high-level overview of kind of what it is. So when I think of malware analysis, I think of three different segments of it. So static analysis, dynamic analysis, and then code analysis. So static analysis is where you're going to analyze malware without executing the code itself. Where dynamic, kind of the opposite. You're going to execute the code and then look at the various behaviors. This could be processes spawning in the malware, network connections it makes, really just a variety of things. And then the last one there is code analysis. So this is where you're kind of get into reverse engineering a little bit more. You're going to start looking at the low-level code like assembly, and you're going to determine the specific functionality of the malware. Today is mostly focused on static analysis. However, I will have a couple screenshots of a disassembler Ghidra, so there will be a little bit of code analysis sprinkled in. So the goals when we're talking about doing malware analysis for incident responders is we want to find some indicators of compromise. So this could be a variety of things. One is suspicious strings. So this could be anything as obvious as like the word evil. It could be the word malware. It could also be completely different things like Windows API calls. Another thing you could look for are domain names. So this could include evil.com, malware.com. They're usually not that obvious, but those are just some examples. And then you could look for suspicious files. So this could be executables, DLLs, ELF files, things like that. And then the last one there is IP addresses are a main indicator of compromise. So now I'm going to get into the more technical part of the presentation. So we're going to look at identifying the file. So this is kind of your first step when you're doing malware analysis. It's really a very important step that sometimes people will forget because you need to identify it in order to determine which tool you want to use. Because certain tools will only work on certain file types. In malware analysis, there's really no one tool fits all. So you can see on the presentation there that one of the most common utilities to use is the file command in Linux. So you can see I got a screenshot there running file against evil, and this is the name of the executable that I'm analyzing in that screenshot. And then the output is very straightforward. It gives you the name of the file, which is evil, and then the file type. So this one is an ELF 64-bit. This is basically just saying it's a Linux file. And as you dive down deeper into your reverse engineering journey, you want to start paying attention to the architecture type, because this will matter once you start looking at it in the assembly code. And the architecture type right here is x86. And this is one of the most common that you'll see. So a big thing I want to go over is the difference in strings versus floss. And these tools kind of serve the same purpose, but they have slightly different functionality. So they're both used to extract characters such as IP addresses, domain names. I mean, you name it, you can find it in strings. Floss does the exact same thing, except it has a little bit more of an advanced capability. It can identify some evasion techniques like stack strings, which I'm going to go over later on in this presentation. Another key difference is floss can only be used with Windows executables, where strings can be used with a variety of file types. So whether this is Linux, Windows, it can actually even be used against PDFs. And just note there that both tools do come default on Remnix and Flare. And the screenshot there, I'm just using the which command in Linux and specifying the binary that I'm looking for, so you can see both of them exist in the user bin directory. So I briefly mentioned stack strings, and now I'm going to go over it in a little more detail. So this is a technique that is used by malware authors to avoid detection, and also they're using this technique to avoid detection by incident responders as well. So the strings utility will not detect this, but floss will. This is kind of one of the key differences between floss and strings. I'm going to go to the next slide for the example. So here's how stack strings would be written in C code. I'm going to do my best to walk through this code just to kind of explain, but this is, at the top here, we're just importing the necessary C libraries. So we're doing an include, the standard input output, and then the string library. And the real main part of this code we need to look at is the modify the string section. So you can see it's really, the name speaks for itself. It's stacking the strings on top of each other. So you can see http://evil.com. And then at the end here, for those familiar with C, this is just printing, or doing the printf function with %s, which is just specifying a string. And then it's printing the http://evil.com. This sample here is not actually malicious. It's just shown for the example. So moving on to a couple screenshots of detecting stack strings. So what I just went over in the previous slide, these are the tools used against it here. So you can see I'm doing strings against the evil.exe. Strings against evil.exe here, and then I'm using the grep command. And for those that aren't familiar with grep, this is just similar to the find command in Linux, where you're just looking for a string in a file. So I'm doing the tac-i option, this is just case insensitivity. So if evil.com was capitalized, it would still detect it. And you can see there are no results. It was able to evade the strings utility. If we look at figure 2 over here is the floss example, and I'm running floss against the exe and running the grep command. Same thing I did on figure 1, except floss was actually able to detect it. So you can see it extracted the stack strings and found http://evil.com. It did pick up a random character I here. This is common. It really just depends how the code is compiled. But the important part is it was able to detect that malicious IP, or that malicious domain. So next I'm going to move into using regular expressions to find IOCs. So a regular expression is an expression used to match various character patterns, such as IP addresses, domains. I mean, you name it, you could use a regular expression to find it. This can be used with the grep command, which I went over a little bit on the previous slide. or it can be automated into a script. I would say most people are going to choose to automate this just to save time. And then an example right there of a regular expression for an IP address is the grep option. And it's important to note you do need this TAC OE. If you don't include that capital E right there, it will see this string as literal and not as a regular expression. And that's just an example. No one's going to memorize these things. That's why on the next slide I included some resources. So one I like is regexer, and this is just a tool to help you create regular expressions you would need. And then another one, this is actually a free training that you can go to online. This is regex1.com. So everything that I just went over using strings, floss, and then finding regular expressions, we're going to try to automate this to save time for future investigations. So I already mentioned it. Why would we automate? It saves time. And then you can use any scripting language of your choice. So you can use Python, Bash, PowerShell. I'm most comfortable with Python, so that's the example I'm going to go over in the next slide. So here's a script to show everything that we previously went over, all automated into one script here. So you can see at the top, I'm going to do my best to walk through this. This isn't meant to be anything super detailed on Python, but I'll walk through the main components of it. But we're importing our libraries up here, and then we're defining our function extract underscores IPs and domains from file, and then we're specifying our argument here, which is file underscore path. So you can see later on in the script, I do define that down here with the input function in Python. And all this is saying is the user can type in what he wants to use for the file path. You can do this differently. You can put the exact path. This is just how I chose to do it for this example. So moving back up here to this output equals subprocess.check. This is just Python's way of saying that we're going to be running the strings command against the file path variable. And then this accept and return, this is just error handling built into the script. And then moving down to the IP underscore pattern and domain underscore pattern here, these are the regular expressions that I just went over, are just put in the script and labeled as variables. And then at the end here, we're just running the IP pattern regular expression and domain regular expression against our output, which we saw up here was defined as the strings output. And then at the end, we're using printf to print them to the screen. So that's all those steps I went over at the beginning of the presentation, all automated into one script. So next, I'm going to move into using Yara for signature. Oh, yep.
Sorry, that script, are you using with remnants?
So this one specifically is with Python, but it is sitting on the Remnix virtual machine. So this script isn't built into Remnix. I had to make it myself, but you can use it on Linux or Windows.
Gotcha.
So next I'm going to move into using Yara for signature detection. So Yara is a pretty cool tool that you can use to identify specific types of malware. The key component is it does rely on a rules file to use Yara. You can make the rules yourself, but most people are going to choose to download them from their favorite GitHub repository. And this does work very similar to those. For those that are familiar with Snort, it works similar to that, except Snort is run against packet capture, where Yara is run against files. So I'm going to break down the basic components of Yara rules. So there's two components, strings and conditions. Strings are used to identify what we want to define in the rule. So looking at the example here, it's under strings right here. We're labeling this A string as evil. And this is a very simple rule. They can get really complex. I just wanted to use something simple as an example. And then the next component of the rule is the condition. And this is the action that must be met to trigger the rule. So you can see this rule, very simple. We're just looking for the A string, which we defined earlier as the string evil. And something I forgot to mention at the top, past rule is evil underscore detection. This is just where we're naming our rule. So next I'll move into running Yara. So once you have it installed, you will need to install a Yara rules file on your Remnix VM It does not come by default, but the Yara utility does come by default. And it's really simple to run. You're just going to use the Yara command and then specify your rules file. So my rules file on the screen there is rule.yar, and then you're going to run it against the executable that you're analyzing. And we're still looking at the evil executable here. So once we run it, you're going to get an output, also very straightforward to read. You're going to get the rule. If something does trigger, you're going to get the rule name, evil_detection, and then the file that you ran the rule against. So now that I've talked about some common static analysis techniques, I kind of want to move into the portion of what malware authors would use to evade some of these techniques. And the first one I'm going to go over is shellcode. So shellcode is used to spawn a shell on the victim's system. And this can contain IPs, domains. Most of the time it's going to contain things like C2s that it's reaching back out to, things like that. And then figure 1 is just an example of what shellcode looks like. This is going to look like garbage to most people, and it looks like garbage to strings and floss as well, because it cannot extract any IPs or domains out of this. So another technique that malware authors will use is hard-coding IPs. So malware authors can choose a variety of ways to do this. One way is by putting the IP in a hexadecimal format. And the easiest way I've found to detect against this is by putting the executable you're analyzing in a disassembler. I chose Ghidra for this presentation. You can use IDA, Cutter, whatever one, or whatever preference you have. So I wanted to touch real quick on what hard-coding IPs will look like in C code. So I'll walk through this here. We're including the standard input-output library, similar to what we did before. And then we're introducing the main function, and this is just specifying it as an integer. And then we're specifying an unsigned character array of 4, and then assigning it 4 values here. And this is actually the hexadecimal. So this 0xFF is 255, and then these 0x02s are the .2.2.2. And then at the end here, we're using the printf function to print the IP address to the screen with the %d, so this will display it as decimal format. And this, another note, is this file is not actually malicious. This is just to show what a malware author would use. So here is the output of that file. When you run that file, which I named hard-coded, it's going to output the decimal IP address to the screen, 255.2.2.2. And then the bottom here, figure 2, is I'm again running strings against the hard-coded executable. And I'm doing the same grep command that I did on previous slides and looking for the 255 address right here. And you can see with the screenshot, it was not able to find it. That's because it is hard-coded there in hexadecimal format. I don't have it on the screen. I don't have a screenshot, but I did run this against floss as well, and floss is not able to detect this either. But there is a way to detect it, and that is using a disassembler. And one I used here is Ghidra. So this is a tool used to view executables in assembly language, and it also has a decompile option to view the code in, it's called like a pseudo-C. It's how Ghidra interprets the code itself. And then this screenshot is of the decompile view of Ghidra. So you can see it's able, highlighted in the box here, it's able to identify the IP address, really the exact same code that was used when it was originally written, but it does identify it in hex format. So you will need to go, the analyst will then need to go back and convert that manually. But that is a pretty good indicator right there. Sometimes the decompile option doesn't work in Ghidra. If that happens, you'll have to look at this in the disassembled view. So here's a screenshot of that hard-coded executable and how it picks it up here. So it does find it, which is highlighted in this red box right here. It looks a little different though. The reason it looks different is it's in little endian format, and this is least significant byte first. Without getting into too much detail, just think of that as the reverse order from the normal order that you're used to looking at. So it's going to have the 2's up front and then the F's on the back end here. This isn't really an ideal way to find an IOC when you want to do something quick for incident response, but sometimes that's the only way you have. So another way to evade string detection is a malware author can choose to pack malware. So when I say pack malware, this is basically saying the malware author is going to compress, encrypt, or modify the original code of the program. And a common packer there is the UPX packer. And this is free and open source and does come default on many Linux distributions. There are also a lot of custom packers that malware authors will use. And you could do a whole presentation, really a whole college class on packers, and because they can get really difficult to unpack. So before we unpack the malware, we first need to identify that it is packed. So how are we going to do this? One of my favorite tools is Detect It Easy, and these are both screenshots here of the exact same file. One is of the packed malware, and one is it not packed. So on the left, in figure 1, is the not packed version. And you can see real quickly, it's able to identify that it's not packed. Another thing you can look for is this score here, this 5.9. It's not a written rule, but generally if the entropy is above 7, which is this number, which is the entropy, it will display as packed. Because if you move to figure 2, you can see the packed version, and it quickly identifies that it's packed, and then it gives it a score of just above 7 here. And then another thing to highlight on the slide is this rectangle here, is it's actually able to identify the packer that was used. So it was able to identify UPX. Detect It Easy cannot identify every packer though. If you go to Detect It Easy's Git repository, it has a list. I think it's like 10 or 12 packers that it can identify. But if a malware author chooses to use a custom packer, it will likely miss it. It will identify that it's packed, but it won't display a packer here. So now that we've identified it is packed with UPX, how do we unpack it? And when it's UPX, it's very simple. Remnix has a built-in utility, the UPX command, and you just need to run the tacd option here. So UPX-D regex.exe, and that will unpack the file. And if this doesn't work, you will get an error. It will spit an error to the screen basically saying not correct packer used, there's an error. And just one thing I want to point out is if you don't use this tacd option, this is basically, instead of unpacking it, it's basically packing it again. So you do need that tacd option. So now that we have some techniques to find various types of malware, and we've discovered some IOCs, how do we use them as incident responders? So it really is pretty straightforward. Once you identify some of these IOCs, you want to query them against the security tool set that you already have. So whether you're using a SIM like Splunk, Kibana, every place has different tools. You want to query it against that tool. And then if you're using like a network intrusion detection system like Snort, you would want to start implementing rules or running Snort with those IOCs. And then if you have EDRs like CrowdStrike, Trellix, query that in that tool set as well. And after you run your queries for indicators of compromise, you then need to verify and then react accordingly. So what I mean by this is if IOCs are found in your environment, you need to confirm if they're true positive or false positive. So if they're actually malicious, you need to follow the necessary incident response procedures that you would normally follow in your environment. And if they're false positives, you want to tune them out and then document them so an analyst doesn't waste time on it later. So this is just a little summary of what I went over today. So going over basic static analysis techniques and then some evasion techniques that malware authors will use in response to that. And then I got into some some techniques to respond to those evasion techniques that malware authors will use. And that is it, and I'll leave it open for questions and comments. Yep, go ahead.
For case the IOCs are encoded, like base64 or other forms, would you also use Hydra, or do you have any other recommendations?
So if you're gonna find base64 encoded stuff, you could still run strings against it because it will find the encoded. You'd then want to pull out those encoded strings and use a tool like CyberChef to decode it.
Hey, we got some great questions that you guys are going to ask, so
Sorry.
Please, let's keep it down. If you're going to exit, go ahead, but do it quietly, please.
Thanks, Chris.
You said the name of a tool in the end.
CyberChef. So once you pull out that base64, you could then use a tool like CyberChef. There's also built-in tools to Remnix that you can decode with decode base64.
Okay.
Yeah, no problem. Yeah.
So I'm coming at this from like a developer perspective. So, and I was just taking a look. So you mentioned incident responders and malware analysts. Are those two separate groups, and what's the difference?
Yeah, I would consider them two separate groups. So malware analysts are going to focus on generally just like the malicious files, or incident responders can be focused on like a whole environment. So looking at logs, PCAP, packet capture, things like that. So incident response a little more broad, malware analyst a little more focused.
Thank you.
Hey, Jared.
Yeah.
If we're asking a question, if you can repeat it, that way we'll have it recorded there. So.
Oh, his question was, what is the difference between malware analysts and incident responders?
Oh.
And then the first question he asked was, if you find an encoding option like base64, what would you do if you encountered something like that?
Okay.
Yep.
Got it. Thank you.
Yep.
You demonstrated many different types of ways to do the incident, many different types of ISVs, like stacks and all that. Would there be any clues to help you know which one to go after? You just run them all and see what pops.
So generally, when I first encounter a file, I will, one, figure out what type of file it is with that file command. And then usually the first thing I run is strings against it, just because strings will catch everything. So when you see like a packed executable with strings, it will look like a bunch of garbage. And the more you encounter it, the more you'll just get more comfortable and know what to pivot to next, if that makes sense. Any more questions? Yep. I actually haven't encountered that.
Personal story
so
on how it fits
I couldn't
the
answer
job.
that question for you.
So, you know, the
Good
resume
question,
is going to get you that interview. The networking on
Yep.
LinkedIn, as you just went over, is going to get you that interview. The interview is what's going to get you your offer. So what, you know, we kind of did was made something that would kind of be representative of a few different scenarios, because what Coca-Cola is looking for, some giant mega company, is different than a startup environment, right? Startup environment might be, you might be wearing multiple hats.
Yeah, so
You might
to
be the
caveat on
content
this
person and the security
is
expert
a lot of
and
these
the
files that you're going to see with stack
person
strings,
that
they
takes
will
the
have
trash out
already
on the way
gotten
out the
caught
door
by
Friday.
like an EDR tool.
And where at Coca-Cola,
So
you're going to have a very,
if
very
it's
defined
really in the
skill
case
set,
if it
very defined
misses it.
responsibilities.
But
So
thanks,
the
good
questions are
question.
going to change depending on the environment you're interviewing in. And as you're doing the
Any
preparation,
other questions?
The young lady that was in the middle had mentioned, you know, preparation goes a mile. Look at the company, but kind of take the cues. When you get your interview invite, if it has, hey, here's some tips on interviewing.
So the
they're
question
gonna
was
be
asked about
organized.
pack files,
If
what's
it's
it
just like,
basing
hey, be there at
entropy off?
5,
It's
good
really
luck.
just analyzing kind of the compression of the file.
It's
so
going to be a little bit
detect
looser
it
of an
easy
interview.
if
So
a
you
file
kinda
was
wanna
zipped,
be
for
ready
example,
both
it
scenarios,
will also
but in a-
identify that as packed. So that would be a false positive. Yep. Yep.
You spoke about detecting stack strings in malware, and with string having the capability to capture everything. What's the timing in terms of identifying what's actual? Any idea?
I just want to understand your question correctly. Can you repeat it?
Sure. So stack. Well, you mentioned stack detecting stack strings,
Yep.
right? And it has the ability to. Is the preferred ability to capture because it captures everything. How do you pinpoint within a timely fashion that this is a true, not a false positive? but a
Oh,
true?
I see what you're asking. So you can use a variety of tools. So if you find if stack strings identifies like an IP address, you can fall back on open source information, so like VirusTotal, You may have other intel sources depending on the type of environment you're working in. You also want to look at the surrounding events to that IOC. So if you're seeing something that looks suspicious within like a 2 or 3 minute time frame of that indicator, you want to start digging down the rabbit hole a little bit further. Yep. Yep.
So I was looking, again, coming more from the developer's perspective, looking at the stack strings and reading the output of Flosh. It looked like it was emulating the function that it's an emulating function as it was building it out. So it seems to me that Floss includes some sort of, I guess, interpreter of the code. Like right there, it says emulating function OX40270.
Yep.
So, I mean, that is pretty nice and interesting.
Yep.
But with that, is there the potential for, let's say, a really crafty malware author to create a function that creates a stack screen, but then also is written in such a way that when Floss emulates it, it breaks Floss?
That's a really good question. So the question was, I showed you a basic stack string. If I'm understanding you correctly, is there a way that a type of version of stack string can break Floss, right?
Or just like, I mean, obviously you're doing this in a virtual machine, so that where if you run Floss on the function, it actually breaks out of Floss and could break into whatever machine you're now analyzing it on.
But a short answer to your question is yes. You can. There are stack strings that can also evade Floss. So the more complicated it gets, it can be missed by Floss as well.
And specifically malware that can infect the machine that you're analyzing it on.
Yes.
That's why we do it at the end.
Yep. Good question. Thank you. Any more? Any more questions? Not seeing any, so thanks everyone for their time. I appreciate it.